Welcome, everyone. It's a pleasure to have you here. And I'm excited to tell you all about crypto and how it embodies a new paradigm for trust. The rise of human civilization is a story of ever-increasing scale of cooperation. Cooperation between people who may reside across political divides or speak different languages or adhere to fundamentally different ideologies. So much of what we have built, our greatest successes as a species, like the internet or space travel, have been efforts that are truly global. But how is this scale of cooperation even possible? It is all driven by trust. But trust is an elusive concept. It is a word that we use a lot, but what does it actually mean? When you boil it down, it's a kind of confidence that doing something or interacting with someone is likely to go well for you. And throughout history, the kinds of things that we have relied on to build trust have changed dramatically. We started as nomadic hunter-gatherers, basing our trust on facial expressions and body language, the signals that we instinctively cue into when we interact with other people. This model of trust was social. Over the many millennia that have followed, institutions like schools or churches or local governments, and then nation states and corporations have come along, and they have helped us scale trust from the very local, where everyone knows one another intimately, to the nearly global, where everyone is a stranger. This model of trust was institutional. It is a predominant model of trust today. But we are now reaching the limits of purely institutional trust. It is too often the case that the institutions that we place our trust in let us down. I mean, think of the recent Wells Fargo scandal, or of the Equifax hack, or of the ongoing drama about user data over at Facebook. Or for that matter, think of the great financial crisis of 10 years ago. Say what you will about crypto, but I think you'll agree with me, there's a lot of room for improvement here. Our technology, and especially our software, has been immeasurably successful at improving a lot of things, but it has only barely started to scratch the surface of the world of trust. I will argue that since the creation of the internet, we have begun to discover a new paradigm for trust. It is a paradigm that is programmable. It is enabled by software, and its guarantees come from something that is more fundamental than a human institution. It comes from mathematical guarantees. Now, to get at what all this means, and to really get at how it works, I first need to break down trust a little further into its elemental building blocks. Now, there are really two important components to trust, two building blocks that together combine to form all of our trust in other people, be it individuals or institutions, and all of our trust in technology. So the first is biological and instinctive. They are the social elements of our interactions. We trust certain facial expressions. We trust perceived social status. We trust brand. We trust reputation. We trust observed track record. Like, this kind of trust is, of course, hard to scale. It takes time and direct human exposure to build. Now, the second comes from our knowledge of the real world. It comes from our understanding of things like math and physics. It is the kind of trust that gives us confidence that doing something as crazy as landing on the moon or going to Mars is even possible. Now, these two components of trust can be used to build a third one, a third building block that we can use to materialize trust, and that is incentive structures. Now, incentive structures could be built from things in the physical world. Like, think, for example, of the physical difficulty of forging a US dollar bill. It offers a disincentive to anyone thinking of trying. I mean, it's just not worth it. It also happens to be illegal, and that itself is an incentive structure, but that one looks like this. It is made up of people. And in fact, most of our incentive structures are made up of people. They are social constructs. Think of legal contracts. Think of all of government regulation. Think of insurance. Or think of the many agreements that we enter all of the time with companies whose terms of service are not exactly page turners. I have read them, I know. The problem today is that these institutions have become the gatekeepers of trust. We are strongly dependent on them to cooperate. The best example of this is our financial system today. In our current financial system, the integrity of any transaction is dependent on the human institution that sits in the middle of it. And the reason that we trust things like banks is, again, because they have a reputation that's on the line, they have a track record, and because there are legal incentive structures that constrain the kinds of things that they can do. Now, let's look at an example. Credit cards. Like, you all know they're not secure. But the reason that you are willing to trust credit cards is because if someone were to charge something to your credit card, you would simply dispute it after the fact. And then at that point, an entire team of trusted humans will get involved and they will get you paid back. Our trust in our financial system today is not based on technology. It is based on that very human-driven possibility for recourse. Now, this model of trust can work in a developed world, but there is no way we can scale that to 8 billion people. As Katie mentioned, there's 1.7 billion people in the world today that are completely unbanked, and the yearly cost of credit card fraud is now up to $190 billion. $190 billion of credit card fraud per year. So in contrast to this limited system, I'd like to give you an example of how trust can work differently. The internet is one of our first examples of a global system of cooperation and trust, where trust is not primarily based on human institutions, or at least it wasn't in the beginning. The early protocols of the internet, call them the protocols of Web 1.0, were a beautiful thing. TCP, IP, SMTP, HTTP, they were built with a spirit of openness and inclusiveness. They were open standards. And this meant that anyone, anywhere, on equal footing, could implement them and build on top of them without anyone's permission. Case in point, hundreds of implementations that are open source exist. And in fact, the code for these protocols running inside of your phone right now to connect it to the internet is based directly on open source code. Think about this. It is a great feat of cooperation that today we have a single global internet as opposed to numerous disjoint networks that fracture along our many divides. Hundreds of countries and thousands, if not millions, of companies all had to converge on running exactly the same protocols down to the last bit in order to connect with one another. And they had divergent incentive structures and ideologies in many cases. In a perennially polarized world, how can we possibly explain this? It was directly a consequence of open source. Because the core protocols of the internet were open source, nobody could take unilateral control over them. Their emergence and support was bottom-up and neutral. They became the stable and level playing field on top of which the ecosystem of the internet could be built. Their emergence led to a golden period of innovation on the internet. Entrepreneurs and their investors could trust that it was a secure foundation to build on top of. But of course, open source is hard to monetize. So the business model of these companies depended on building proprietary protocols on top of the internet's open ones. So these were the protocols of Web 2.0. A handful of these startups, you may have heard of them, went on to become some of the most valuable and powerful companies in human history. And of course, their emergence has actually led to technology that billions of people have gotten access to, mainly for free. And that is truly phenomenal, because these technologies are literally superpowers. And as of late, these companies don't really get enough credit for having done that. But there is an important caveat, and that is that these companies have now become the new intermediaries, the new gatekeepers of trust on the internet. For most of what we do online today, be it search the web, connect with other people, share and experience media, we are now forced to trust in proprietary code that is written by these companies. The result of this is that these companies now wield inordinate power over their users and their developers. By virtue of their control of all of the data, these companies control every single interaction between users on their platforms, every user's ability to exit and switch to another platform, content creators' ability for discovery and distribution, all flows of capital, and the relationships between third-party developers and their users. They also control the rules of the game. They can, at any time, without warning and almost entirely on their terms, change the rules about how their platform works. They can and do this often, and they disenfranchise companies in the process. We've all seen the headlines. Facebook, Zynga. Twitter, Tweety. Google, Yelp. And the list goes on and on. The behemoths of Web 2.0 have reintroduced themselves into the trust equation of Web 1.0. We went from this trust model to this one. Now, the story of the internet serves as both inspiration for how much value creation is possible when you build on top of a platform that's neutral and fair, but also as a cautionary tale of what can happen when you place too much trust and power in a small number of for-profit institutions. The trust model of Web 2.0 is not like the one of Web 1.0. It is inconceivable that you could build a company the size of Google on top of Google in the same way that Google was built on top of TCP/IP. So the question is, how do we get back to a model of trust without gatekeepers? Or in other words, how do we go from don't be evil to can't be evil? All right, well, the moment that we've all been waiting for. Who wants to talk about crypto networks? And nobody? Oh, that guy over there. Great. This entire presentation can be summarized with a single big idea. Crypto networks are a technology that has the potential to catalyze trust and therefore cooperation at a scale that is unprecedented. They will help with bringing about a shift from institutional trust to programmable trust. Now, I want to talk a little bit about the technology. Crypto networks are built on top of the open protocols of Web 1.0 and on the building blocks of cryptography, therefore, crypto networks. Now, one simple way to think of cryptography is as the branch of math and computer science that studies how to make data trustworthy. Now, when you hear the word cryptography, you may be tempted to think of encryption, of keeping things secret. But by far, the most important application of cryptography today has nothing to do with secrecy. Rather, it is all about helping make data tamper-proof. Digital signatures, for example, are a breakthrough of modern cryptography that allow me to send you a message and for you to be mathematically certain that it actually came from me. Now, the digital signatures of cryptography and the other building blocks in that field, plus the open protocols of the internet, are a very powerful combination, and they have gone a long way towards enabling the internet. But they are not a complete set of Lego building blocks to serve as a true software platform. There are protocols that are missing. For example, there's no way to use these protocols to store user data, or let alone to compute on top of that data. The tech giants of Web 2.0 built fantastic businesses by stepping in and providing proprietary versions of those protocols. What we would want instead, though, is a set of protocols that are open, like the ones of Web 1.0, that make for a repository of user data that is neutral and collectively owned by the users themselves. This would mean that no one human institution would be in control over it. Now, of course, building such a database is very hard. After all, someone has to do the hard work of securing it and keeping it honest. Traditionally, we've relied on companies and banks and governments to secure our databases for us. But what we want instead is for trust in the database to come from math and physics. In other words, the database must be self-policing. Almost exactly 10 years ago, the Bitcoin white paper was published. The idea behind Bitcoin is to leverage, again, the open protocols of Web 1.0, plus the building blocks of cryptography, plus an exceedingly clever incentive structure to build a community-owned database of Bitcoin transactions, of payments. Now, what is truly novel about this database is that its security emerges bottom up from users. And these users can be anyone, they can be anywhere, and they can participate without anyone's permission. In other words, control over the database is decentralized. There are no gatekeepers. The challenge with this, of course, is that no doubt some of these users are dishonest, and they would rather like to game the system for profit if they could. The genius of Bitcoin is an incentive structure that helps the network be self-policing, and thus makes it secure. Now, I think it is valuable to have at least an intuition for how Bitcoin works. So if you bear with me, I would love to walk through it with you. Instead of keeping a single copy of the database inside of some trusted data center that's owned by Google or Facebook, the participants of Bitcoin keep a copy of their own locally. Every participant has a copy. But there's a problem. How do we make sure that all of these copies of the database remain consistent with one another? And how do we make sure that no one is inserting fraudulent transactions? The answer is that each participant, known as a miner, continually monitors all of the activity, all of the transactions on the network, and votes for the sets of transactions that they consider to be valid and honest. Now, the twist is that they vote with their computational power. So consider Alice. She is a miner. The more computational power Alice offers the Bitcoin network, the more secure she helps make it. And as a result, the protocol gives her more voice in the form of voting power, and also gives her a financial reward. Now, crucially, the financial reward is paid as newly minted Bitcoin. The protocol mints new Bitcoin and pays it to Alice as a reward for contributing security. And so, in a single stroke, Bitcoin comes alive as a new form of money, and at the same time, as the very source of funding that bootstraps its own security. This idea is known as proof of work. The insight is that you have to contribute something to the network in order to get to vote and to get paid. The result is an elegant incentive structure that encourages mutually distrustful participants to keep each other in check. And in doing so, even though they don't trust one another, to come to trust the database that they are collectively helping secure. And voila, it works. Now, Bitcoin is the simplest possible crypto network. It attempts to address the problem of trustless money. Money whose legitimacy and backing depends not on a human institution, but rather on mathematical guarantees. And all of this is great, but someone else came along and asked the question, is it possible to build something that is more interesting than just money with this idea? In 2014, Ethereum was launched. Its provocative insight came from the thought that there's no reason why the Bitcoin database needs to be restricted to just money, and there's no reason why updates to that database need to be just payments. Those updates could actually be whole computer programs. Ethereum is therefore more than just a decentralized database. It is a decentralized, collectively owned world computer. Now, programs that run on top of it, once deployed, are also collectively owned. Now, this means that no human institution controls them. In a sense, they are independent. Once written, they obediently execute their instructions as written, subject to nobody's authority. But why would anyone want independent programs like this? Well, you may very well be able to guess. It has to do with trust. Programs of this kind are open source, so everyone can see what they do. Their correct behavior on the world computer is mathematically guaranteed. And so, they can be used as building blocks for agreements or smart contracts between complete strangers without the need of mediating authorities. For the first time, we have the ability to program trust. Now, I want to work through some real-world examples of what you can do with this. One ingenious application of this idea is a cryptocurrency called DAI, which is price stable with respect to the US dollar. This is what Maker is building. Now, the beauty of DAI as a cryptocurrency is that it has all of the advantages of Bitcoin, but it is also price stable. And it is because of that stability that it is a credible digital alternative to fiat in countries where hyperinflation is a problem, or for the 1.7 billion people who are unbanked. Now, Maker launched DAI almost a year ago, and it's been in circulation ever since and has defended its peg against the dollar beautifully, even through the crypto downturn. But you might think that this idea should be impossible. I mean, after all, the price of something is always determined by the market, right? And what gives us the ability to proclaim that something's going to be worth $1? Always. But the ideas behind DAI are very clever. So if you bear with me, I'll try to explain this. DAI is simply a program that runs on the Ethereum world computer that mints DAI tokens and hands them out as loans to anyone who is willing to post collateral for those loans. The collateral is formed of other crypto assets, like Ethereum. Now let's work through an example. Bob wants to take out a loan. So he deposits to the program $200 worth of Ether. And he takes out as a loan, say, 100 DAI. He can then go on and spend the DAI as if they were dollars. They can go out in circulation, they'd be traded in exchanges, and that is the price-stable cryptocurrency. This is sound because every DAI in circulation is backed by at least $1 worth of collateral. Now, of course, there is an obvious problem. What happens if Bob's collateral starts to go down in value? Well, this is where the magic of software kicks in. As soon as any one loan, say Bob's, becomes too risky, the program has the ability to take possession of the collateral, sell it for DAI, use the DAI to close the loan, and as a result, take the DAI out of circulation. The end result is that every DAI is always backed by at least $1 worth of collateral. Now, take a second to think about that. DAI is not just a price-stable cryptocurrency. It is a lending platform. And it is a lending platform that originates loans and margin calls them entirely in software. Now, I don't know about you, but I think that is extremely cool. Like, the kind of glimpse that DAI offers of the future is the kind of thing that gets me out of bed every morning. Now, let's take the idea of lending even further. Compound is a company that is building, again, a program that runs on the Ethereum world computer that acts as a kind of money market. Anyone can lend crypto assets to the program, and then the program will then in turn lend out those crypto assets to someone else. The interest rates are algorithmically computed, and again, no trust is placed in human institutions, no banks. Now think of what you could do if you were to combine Compound with DAI, which is the stable cryptocurrency that you could issue loans and borrows. This starts to look a lot like a consumer bank. But it is a consumer bank that is built entirely in software, end-to-end. Now, I want to go beyond just finance. What else can we build with programmable trust? One example is a programmable marketplace. In this case, a programmable marketplace of storage. It's called Filecoin. I can rent you the spare storage in my laptop, and you can pay me for that storage in Filecoin. Crucially, you and I could be complete strangers, and we could reside across the world from one another. You can trust that I will store your files, and I can trust that I will get paid for that storage because of the mathematical rules and incentives of Filecoin. And again, there's no company in the middle, just the protocol. This is a CryptoKitty. I happen to own this CryptoKitty, and I also happen to be a little bit embarrassed to admit to you how much I paid for this CryptoKitty. So this CryptoKitty is mine. It's a kind of digital collectible Tamagotchi Beanie Baby kind of thing, if any of those words mean anything to you. Now the difference here is that it's a purely digital thing that the world recognizes that I own. Think about it. You can use the technology to track how much Bitcoin everybody owns, but you can just as well use it to track who owns all of the adorable cats that happen to be playing starring roles in Pokemon-like online games. I mean, why not? No matter what happens, even if the company that built CryptoKitties were to go away, this kitty is still mine. My ownership of it is burned into the Ethereum blockchain. I can take it with me and into another game. And that is something that is truly new. This is just the beginning of a new paradigm for web-based games. Now, the technology in the space is still very nascent. It is the very beginning. Countless building blocks are still missing. There are many problems of performance, problems of privacy, which is still missing, problems of custody and key management, problems of identity, KYC, AML, problems of developer experience, user experience, problems of governance for the protocols, and the list goes on and on. But as these limitations become addressed over time, they will serve as a new set of Lego building blocks that we'll be able to use to build things that we can hardly imagine today. Things as complex as social networks or search engines that will become platforms in their own right. Like the protocols of Web 1.0, the crypto networks of Web 3.0 are open source, collectively owned, decentralized, and neutral. We see this as the foundation for another golden wave of innovation on the internet that may be even larger than the current startup ecosystem on the internet today. We can hardly hope to imagine what this wave will look like when all is said and done, but we can see the beginning of a progression. It starts with addressing some of the inefficiencies in our current financial system. It progresses to the programmable marketplaces like Filecoin, and onto crypto-enabled games like CryptoKitties, and finally, to an architecture for the internet that can serve as a platform for the yet uncharted Web 3.0. This is a fundamentally new paradigm for computing. We've gone from mainframes to the personal computer, to the smartphone era, and now onto crypto networks. The key feature of this new paradigm that is previously unheard of is that trust can now be software. It can be programmed. And through programmable trust, crypto networks stand to allow us to scale cooperation in a way that is completely unprecedented. Trust is becoming unbundled, decentralized, and inverted. Instead of flowing top-down from institutions down to individuals, it is beginning to flow bottom-up from individuals and from software.